think we can get started. I think there are more people are coming, probably, right? All right, let's pick up where we left off last time. We talked about text processing. Text is a bunch of strings, right? We talk about how we have to clean it using regular expression. We did some practice questions for that last time, and then we talk about what you have to do with the text after that, which is text processing. So the idea of text processing is mostly you want to put some linguistic structure over your text. And we talk about word segmentation and how that can be a bit tricky based on the language that you work with, because each writing system has its own quirks of how we process it. And we talk about 4 methods for tokenization. They all have pros and cons, different key components. Some are more customizable, some are more geared toward languages that don't have spaces, such as Thai, Korean, Japanese, Chinese, right? So that's what we left off from last time. So today we'll continue talking about text processing, and then we have a little bit of activity to let you use some of the tools and see how that works out when you use the tools. See what weird things that you can look at. All right. All right. All right. So word segmentation. We left off at word segmentation last time. On the contrary to many popular beliefs that Thai is very hard because word segmentation. Not true. Thai is hard. It's just as hard as other languages, but for very different reasons. But word segmentation is not really your worry. This seems like an old belief, but every once in a while, somebody would talk to me, oh yeah, you work on Thai natural language processing? I heard Thai is really hard because there's no word boundaries. Like, okay, what about other stuff? Trying to understand conversation, trying to understand the whole discourse, trying to understand the whole news articles. Those are much harder, okay? So word segmentation, you should not worry about that very much anymore. Okay, so we have some checklists for text data cleaning. So we talk about what to do with the symbols, with the numbers, are they important? What about the non-language part, like emojis? What are you going to do with those? Hashtags or handle names. So that's up to the analysis that you want to do. And other than that, back in the day, we think about something called stop words. I will talk about stop words for just a little bit because it's used sometimes, but not so much anymore. So stop words are, I did not have the slide for that. The stop words are words that don't have meanings. What are those? What kind of word doesn't have meaning? So it's mostly grammatical words like is, of, my, the, a, and, over, in, so those are those are the words that you see a lot in text. So when we work on the real data today, you see what those stop words are. So stop words are things, things that you think don't have any meaning, but they do have meaning, right? Is, am, are, was, were, would, will, they all have meaning in their own way, but not when it stands alone. Okay, so sometimes we remove those, but not so much anymore. Okay, and lowercase the data. Sometimes we want to lowercase the data just so that words that are, for English anyway, the words that are capitalized at the beginning of the sentence got considered as the same as when it appears in the middle of the sentence. That's what it is for, but then you got into trouble like when you have words like Dan Brown. Dan Brown. Dan Brown is a good writer, a novel writer of sort, right? So Brown with a big B and Brown with a small b are quite different, actually. So Brown with a big B is a very common last name in the Western world, right, Brown? So when you lowercase it, you lose something. So we try not to clean that out anymore. So we leave things the way they are now, all right? And stemming. Stemming, sometimes we use it So many verbs and nouns and adjectives actually in many languages, you can change the forms. You know, when you learn English back in high school, middle school, it's all about changing the word forms into the right form, right? You know, changing to the past form, the ช่องสอง that we call it, right? And the ing form, the gerund, and so on, right? So to stem it, we stem it down to say searched, to searching, to just search, just so that when we aggregate, when you sum them up, when you count them, they count as the same. So when you use your search engine and you type in playing and play, it should bring the same pages. That's what we did in the past, but not so much anymore. But just so you know, that's what some people still talk about, and some of this still used. Yeah, but I won't stress it as much. All right, let's finish up linguistic pre-processing. We talk about word segmentation. Sometimes we talk about sentence segmentation because sentence is great, right? What is a sentence? Sentence is actually, it's hard to say what a sentence is, right? So a sentence is usually something that we consider a unit that convey one meaning, whatever that means. One meaning, okay? หนึ่งใจความ, you know, that's what we learn, right? But also sentence in linguistics, we think of something that you allow to be grammatical. So when you talk about grammar, right? We talk about the grammar within one sentence. How you build up a sentence, that's all about grammar. So we think of sentences as a grammatical unit, okay? So it depends on what that language allows you to say. So that's a sentence. All right, so sentence is great because then we can process one chunk at a time. You know, a word doesn't really do much, right? Until it's put in a sentence. That's when you actually get to understand the meaning. So that's what we kind of like to do as well. We want to break a long string into a bunch of sentences, and then we can process those. Oh yeah, English. How do we know that a sentence ends and another one begins? So if you see a blue slide, it means that I'm asking you. It's not a rhetorical question. I'm actually asking, and we'll wait for your answers until we can proceed. Say again? Punctuations, yes, very good. So most people think just period, right? The full stop, we call it, but also other punctuations like question mark or exclamation mark. So the surprise punctuation. So those turns out to be very, very good, except when you have some sentence that's in a quote. That's when it gets kind of messy. So yeah, so you can use regular expressions. So regular expressions, you could use it for cleaning data. You can also use it for word segmentation for some languages, and can use it for sentence segmentation as well. But there are other annoying things. For example, dr.attapol doesn't work at Google, Inc., full stop, or dot, right? So the first dot, first period, is not really a period, right? Because it indicates an acronym. So you cannot always use that. So what people did is you have a bunch of common acronyms, and the period that come after those acronyms, they say that it doesn't count as a sentence boundary. Okay, so if you look at the tools, NLTK, which we will look at today, they have a long list, like the title like Mr. Mrs., Lieutenant General, Attorney, something like that. They have a long list of common titles for people's names. Okay, so those will not count. So you basically write a really long regular expressions to use as sentence segmenter. And what about the second one? I think the accuracy is 10.5% dot. What does the dot do? You know, you're not sure. I think, and you see that in text, right? The dot. So they also make an exception for the dot. And also the dot that are surrounded by numbers also don't count. So you have to deal with these things, okay? And again, good news, it's not very interesting. So we will not talk about it in any more detail than this. And I will leave it as that's a tool that some really smart people made for us, and then we use them, okay? Life is good. You don't have to write everything from scratch anymore. This is a good time to be alive. Oh yeah, so 2006, they used machine learning, and they used some really interesting statistical approaches to segment sentences. So basically, they look at words that are capitalized, and that should be a very good sentence boundaries. Again, not always, right? Not always. People's names, also capitalized, right? So it's noisy. It's a very noisy signal. So they do something with it using this insight in the way we write. Not going to go into the detail, but they use something around that. But the accuracy is very high. Okay, but if you look at these languages that are in the table, so each one is each language: Dutch, English, Estonian, French, German, Norwegian, Spanish, Swedish, Turkish. Okay, this comes from the paper I just mentioned, and the errors is there's still error. So this is machine learning. That's always errors, right? But it's around 1%, except for Estonian is 2. I know very little about Estonian, but what these all have in common, though, that they use basically the same writing system. They're all different languages, the same writing script, the same writing system. Maybe for Turkish, they put the symbol above and below, and they have the C with the tail. They have like other characters that we don't see in English. Or French would have, the accent, above and below to indicate the sound. But for the most part, they are kind of the same. Okay. Cool. This is the code. It's very simple. So you install an LTK, which we will get to use today, and download the model. Okay, so the model is roughly come from this paper, and import this tokenizer, and then as in it's a sentence tokenizer, so it will break this string into this list of strings. This is a sentence dot, and this is another one. Are you enjoying it? So these are 3 sentences that we segment. Very simple, okay? Nothing very complicated. The code for this class is never complicated because people write tools for you. And today I'll show you how to use those coding assistant, which is now built into Colab. Is amazing. You don't even have to go back to ChatGPT and copy it over that step. You don't even have to do that anymore. You can use it straight out from Colab, which we will look at today. Oh, the blue slide again. What about Thai? How do we know that a sentence ends and another one starts? Spaces, okay, spaces. Noun. Yeah, usually a subject would begins as, will be at the beginning of the sentence, right? Okay, that's an idea. No spaces, that's good. Now it's good. What else? Don't think too far yet, okay? Think about when you read, yes. Context. Context is a really well-hated word in linguistics and NLP because it's just so big. What kind of context, right? Context can mean like words around it. It can mean the meaning that the words surrounding it convey. It can mean so many things, something more specific, maybe. A new paragraph, okay, yeah. So if you start a new paragraph, it's definitely the end of the sentence, right? Okay, that's good. Think about when you read a page of like Thai text. How do you know that a sentence ends? Just intuitively, don't think about program or model. Yeah, just think about like, how do you know? Oh, that's the end of a sentence. Wait, that's an object. Okay. What else? The ending word, such as ka, kap. Okay, yeah. Ka, kap is those are they call sentence final particles because it does end the sentence. Yeah, kap, ka, la, si, those can only appear at the end. So that's good. There are more because we don't use those all the time, right? If we don't always end the sentence with the object too, you can end it with anything, really. It's a very hard question, okay? so I don't want to admit that the best answer is context. and because context is so hard to make it into a program, as of now, we actually do not have a good Thai segmenter because it really depends on the context, okay? It depends a lot on the grammar, actually, and also the context, which is both of them are quite hard to make into a model or a program. So yeah, it's quite difficult, but spaces are very good. Usually a sentence ends with a space, but a space doesn't always end a sentence, if you know what I mean, right? A space can separate dependent clauses or the modifiers. Space can be between the text and the numbers, right, in Thai. Space can be between English text and Thai text because it looks nice, okay? we use spaces because it looks nice so that we can pause, so that we can separate the two scripts. So that's why it's quite difficult, okay? It's quite difficult. I had one graduate student of mine. He worked on sentence segmentation in Thai for his master's, and it turns out to be really difficult. And we tried for like 2 years, 3 years to try to do this well, and it turns out to be quite tough, even with the modern NLP models. So it's still open. Yeah, this paper from 2021, they claim that they could do 92% range kind of performance, but never seen it used, okay. All right, so that's the sad thing about Thai segmentation. We don't do it because we don't have a good way to do it. I try. If you want to try, let me know. You can find ways. It's a really good, it's a very good topic. Last thing is morphology, morphological analysis and normalization. So, as I said before, in English and many Western European languages, they love their morphology. Morphology means when you morph a word form. That's what English has. That's what makes English hard. That's what makes German, French hard, because you have to change the form of the word to conform with the grammar. Okay. So, say for example, seek, we call that an infinitive form, if you remember from high school. And you have present form, the verb ช่องหนึ่ง singular we call it in Thai, right? We have the verb ช่องสอง which is a past form, and the third the third ช่อง the ช่องสาม the participle form is also sought, right? So you have to sometimes you want to convert that into the infinitive form, all right? And have participle form, seeking, seeker, which turn the verb into a noun, etc. So there's a lot of those in English. So Thai actually easier in this sense because when you learn too, and also when you write a program to process the text, Thai has almost no morphology. We never change the form. Yes, something easy. See, like word boundary, sentence segmentation is hard, but morphology is easy. It's always something like this. All right, that's never a hard language. It's always a hard language in some sense. Matches, plural now, singular now. So we could change it back. There are algorithms and models to convert it back to the infinitive form. Not easy for some reason. Not very easy, all right? Because then you have other words that you don't see before, but people can convert it back, but sometimes model cannot. I'm gonna leave it right here. Lemmatization, stemming, sure. Okay. I just want to get out of this thing so that we can talk about machine learning today. Okay, so there's some technical things that I want to talk about a bit actually. So for a word, you already change the form and use it in a sentence. That's what we think of a word, right? And there are two base forms, so to say. It's a lemma and a stem, okay? A lemma is what you would see in the dictionary. So it's a real base form. So for example, if you have a seeker, you would see in the lemmatized one would be seeker as well. But if you stem it, stemming means you remove all the prefixes and suffixes so that it gets the normal form. Because we know that to get seeker, you have seek, which is the base form, and you add ER to it to make it into a noun, to make a verb into a noun, which means a person who does that verb. Okay, so these are the difference. And if you look at sought is a ช่องสอง of seek, by the way. So there's no seeked, okay? So if you lemmatize it, you change it to the base dictionary form. This one is hard. This one you need to memorize, right? But if you want to stem it, sought doesn't use prefix or suffix from seek to make it sought, okay? So when you stem sought, you get the same thing back. So in tools, NLTK that we use today, that's a stemmer, and that's a lemmatizer, and that's the difference. We will see stemmer again when we talk about search after the midterm. So stemming will come back, right? Oh yes, so we finished up from last time. So text, a bunch of strings that encode language data. Usually we use Unicode for it, and you can look at the Unicode chart and see how each character in each language got translated into Unicode, right? And a corpus is a collection of texts that are created in a specific way, using specific sources, specific authors, or a time era, or certain domain, okay? That's called a corpus. And to create a corpus, or to do useful things with text, we have to clean the data before we put it together and select just the parts that we want. Strip off the HTML tags, strip off hashtags, and other dirty things that are in the data. And then we usually perform automatic linguistic pre-processing, which is usually just word segmentation, right? That's text processing, but we haven't processed any text yet. So for the next 10-15 minutes, I'm gonna teach you how to process text as in word segmentation. I would not ask you to clean the data because cleaning data is not, it takes long. So, all right. So For most of the time, we will use Colab. Everyone knows Colab? Yeah? That's what allows you to code on an iPad, which I do not recommend because the keyboard is kind of tricky to use. So if possible, do it on the laptop. Yes.
So is this the model we're going to use heavy? Because last semester we also used Colab.
Okay.
And most of our credits, GPU credits are.
We would not train anything GPU intensive in this class, I think. Not sure yet. I think we will, but I'll get to that later. But for now, we will use Colab just because it's easy to install things. Sometimes I have a hard time installing some packages on a Mac machine, which should be like the easiest thing. But so to take care of installation, Colab is the best choice. All right, let's do this. Okay. So you will find that Gemini doesn't do everything for you, right? So you still have to do some stuff like tell it where the file is and how to read it, because say for TNC, it's annoying. I try to make it annoying for you because it's in many files, right? Yeah, so you could, I'll do the Thai part for you. I think most of you already got the English part, okay? So, what do we do? Grab all of the file names in TNC3 Unicode sample 15, right? Unicode sample 15 folder. Read all of the files and concatenate them into one single string. Okay, so when you vibe code, we call it vibe code, right? You know this term. So we are vibing right now, but don't vibe too much. Just do step by step would be the best thing. So now we don't tell Gemini to do everything all at once, right? We do step at a time. First, we want to read the data, and we tell that the data is in this very annoying form, okay? Because there are many files. So we want it to read all of them, and then, so I have to tell them what folder is in, read all the file, and concatenate into one single string called, what should we call it? Data, okay? And then that should do it, maybe. Sure. Okay. Real file name, OS path, join, Oh, okay. Maybe it's correct. Look at the field string. It has 2 million something characters. Should be fine. But look at it a bit, wouldn't hurt, right? Okay, yeah, there's some string in there now. That's awesome. Okay, and tokenize using PyThai NLP, right? Let's see, it can do that. Tokenize using PyThai NLP .word tokenize. I happen to know what function, so tell it if you happen to know. Tokenize string data using. And then what do we need to do? Count the find top 100 most frequent words. That should be good. Sure. Don't run it for me. Let me look. Okay. Yeah, we word tokenize it, keep white space false, okay. Use counter, use counter, and then command 10. This is actually correct, I think. Okay, so when you vibe code, make sure you understand each line. No module name PyThai NLP. Okay, sure. Pip install, we know that. See, we don't have to vibe code everything. We can we can troubleshoot like, oh, there's no this module doesn't exist. Install it. So you should know basic. All right. All right. Let me run this again. Should it take this long? Right? Okay. Does it take long? I don't like this. Yeah, 40 takes too long. Maybe the string is too long, I think. Five minutes. Well, now we know that it's not a good idea to tokenize 2 million characters all at once. Maybe we'll tokenize one file at a time. Would be a better idea. Yes. It probably tried to allocate memory to do, because it does maximal matching, which we learned last time, right? So it's some dynamic programming stuff that takes long. So let's kill it. Now we know it's not a good idea, okay? It's not even machine learning. This is dictionary based. All right, sure. So I won't concatenate it. I would turn it into a list. All right. So I'm not vibing. I'm gonna change the code manually, okay? Gonna store each string from each file in a list, and then we'll tokenize each one at a time, and that thing should be okay. Thank you. And then for file, data in data, and then we'll tokenize it. And I'm not gonna vibe it anymore. Okay, so now we have tokens, and then we word count. Whoop, that should be good, I think, right? Something like that, I think. Should be good. Let's go. Still long. It takes a while. So yeah, it is something like that, right? Did it take long for you? No? Okay, so it took me 40 seconds. Okay, better, much better. Okay, I'll give you the code. So the most common is empty space and t ของในการ dot จะและมีเป็นได้ and big space. So if you really want to, you could write regular expression right here. Whether you want to count it or not, you could do that as well. But yeah, for this assignment, this is okay. Okay. But if you really want to, you could write regular expression here to count it. So if re dot match, right? Yeah, that's fine. Yeah, that's fine. Yeah, into yeah. Only top 100 though. Don't give me everything. Okay. So if you go to Garan, right? Plus 2 token, then we match the token, and we can wait 40 more seconds for this. So yeah, the code should be something like this. So yeah, you could, you remember this regular expression, right? So this is the range of all Thai characters, and plus, that means at least one. Okay, so the token that we would count will have to be Thai strings that doesn't have any, that don't have any punctuation in there or English characters in there. So it should take us another 10 seconds. It's very slow compared to English. English is like instant. All right, okay. Okay, that looks better now. ที่ของในการจะและมีเป็นได้ใช้ให้ข้อมูลว่าจากถึงซึ่งหรือ Okay, so yeah, something like that.
So you want it like this for Thai language?
Yeah, yeah. So if you want, you could add this regular expression to keep just the Thai tokens only. But yeah, I don't require you for this one. Okay. Again, don't worry about this homework thing. Put something in there, and you'll be given credit. Okay. So it's not. I won't give you like 0 to 10. So just so that you are it's participation grade, so to say. Okay. So just copy in something you've got. English or just English, just Thai. Yeah, anything you have now. All right. Good. So the takeaway I want to give you is don't vibe code everything. If you want to vibe code, one step at a time, okay? Like reading data, one step, tokenize one step, count one step, but I do it in one step for the second and third. All right? I'll give you this code. So, or if you want to take a picture, yeah, go ahead. All right, so it's a good way to review regular expression now because we are using it here. Good, and that's it for text processing. It's something like this. Files are usually quite annoying, right? In many files, in single file, in zip file, tar file. So that's good. Useful command, guys, unzip. Because most files that you get, you will be in a zip file, and you have to, it's convenient because when you use Colab, you usually zip it into one file and upload because it will be much faster. And if it's a tar file, you can use the Unix command to extract it. Don't use Python command, it's really ugly. Most of you use Python to extract tar file, the tarball, we call it a tarball. Those are much harder. I think the command for extracting tarball is like tar xvf something and followed by the file name. Something like that, yeah. X for extract, V for verbose, F for file. But you can always look that up, okay? So this is another useful command, Unix command that is useful. Okay, tar-xvf. Cool. And I just noticed that the zip file I give you cannot be opened on Windows. I zip it using Mac, so I guess it's different kind of zip. But anyways, computer, it's hard. All right. Let's talk about machine learning for half an hour, and then we'll take a break. All right. And I heard you guys already learned something about machine learning, right? So this is not new, right? If I go too fast, just like, hey, too fast, because I'm assuming you have seen machine learning, okay? All right, so we talked about text processing already. Now we talk about basically the rest of this class will be machine learning for NLP. So it's just an intelligent algorithm that learns from data. And that's the best thing we can do for NLP. We will learn from data. So there are three paradigms that we use now. First, you probably see that already, supervised machine learning algorithm. This is the best machine learning algorithm we have. Even ChatGPT that we use now use some of this, some of supervised ML. So it means you need a pair, you need samples of input output for the task that you want. Okay? So we call that a label data or supervised data. So label is a thing you put on something, right? So that's a label. All right, and so supervised ML is pretty much the same as you have seen before. You need a training data. We call it training data because the algorithm will learn from the training data. And for example, for the word segmenter, you hire a bunch of people to segment words by hand, and then use the input-output pair, feed it into the machine learning algorithm. For beginners, you usually just don't look at the data at all. You download it from Kaggle, and then you vibe code using Gemini or something, and then you throw that data into there. It will train the model for you. It's quite straightforward nowadays to do that. But we will talk about the detail later, how to make a good model, not just a model that you train on Kaggle. All right. Look at sentiment analyzer. I translated the data because we know we have some non-Thai native in the crowd, which is great. International environment, I love it. So again, sentiment analysis, we use this a lot. So we also have a training data, which is an input-output pair. So the input is the samples of how people express their sentiment, and the output is the label. And again, you feed it to the machine learning algorithm, which we'll spend the next month talking about. So to train a model, it means to make machine learn from the data. That's all. That's what it means. This is a technical term somehow when we say, oh, we have to train the model for this long, train the model on what data set. Supervised learning, unsupervised learning. Unsupervised learning is mostly about grouping, okay, because there's no output. So we look at a lot of data and try to find ways to group it, okay? I also translated this slide to make it more international. So we have a corpus, and say we want to sort it by themes, by topics. So we have this thing called topic model, which is a machine learning algorithm as well. We will not talk about this one because we wouldn't have time, but it can sort automatically based on the word statistics in the document. So at the end, you have a word list based on the frequency that it appears in that cluster. So in this case, in this example, it's 3 clusters. So the first clusters, you can look at some top frequent words, and you see that it's about entertainment, films, and all that. The second one, you will see that it's about financial news, and the third one is about like athletics, sports, okay? So from word frequency, you can do something like this even. So we cluster them by the pattern of word frequency. We will not talk about this model, but actually quite useful, but you can learn that on your own. Oh, this one is cool. So this is essentially a question answering system. So we have a question, right? Why do prices rise in poor countries? Why do they rise? Why do they increase? And if you want the answer, one of the good ways to have a question answering system is to find a document that sort of answer the question. So essentially you group the document based on the meaning of the question. So for example, the first one, money printing and weak currencies make things more expensive in financially weak nations. Financially weak nations means poor countries, right? But the string looks totally different. But there has to be an algorithm that figure out the group of meanings. So once you know that two pieces of text have similar meaning, then you can do something like this. You can do search. You can do question answering. So we'll explore this later in the class. So we'll talk about question answering too. Transfer learning, we use that a whole lot more now. ChatGPT, large language model, uses transfer learning, and the basis of all modern NLP comes from this, because we say that label data is not enough because it's too small, too expensive, and you start from zero. We change the paradigm now. This is the only thing we do now. So we pre-train the language model. We pre-train the model so that it has some knowledge of the language. Okay? Once it has some knowledge of the language, you could train it to do specific things. How to train it to do specific things? You use the training data. So you combine it with supervised learning. But you don't start from zero. You start from a model that knows something about the language already. So if you've seen computer vision before, that's exactly what they do as well. So you have a model that knows something about the visual world, how to recognize some objects, and then you can train it to recognize some specific objects. So we borrow the idea from vision, actually, which is very successful. All right, so we have two steps, pre-training and fine-tuning. Large language model also do this, pre-training and fine-tuning. That's what make LLM really good. So that's machine learning, okay? So we're gonna use all these three techniques in combination. But let's talk about the simplest way of using NLP models to create NLP applications is to build a text classifier, okay? So text classifier, class mean types, right? Different classes. IFI means to make it into classes, right? So that means you're gonna distinguish into different classes that you specify. So that's what classifier means, right? And text is text. We know what text means. We just processed text 10 minutes ago. So it's about having predefined categories, which is the output, all right? It has to be predefined. You have to know what categories are you talking about, all right? So we want a classifier. We want a system that assigns the category to the text. So the text that you input, the label or the categories are your output, okay? So the text input could be just about anything. That's why we just say text. It could be a word, can be a character, can be a sentence, can be a document, can be a set of documents. It can be any text you want. And we will build models differently based on the label and the type of input we receive. Let me give you an example of sentiment. I've talked about it a million times. Let me skip this one. Spam classifier, we talked about it last time as well. Spam classifier is really important now, but now people move on to like hate speech and all that now. Okay, so when people say something that's really not a spam, but it's really hurtful, you read and then you are angry, you read and you feel unsafe, for example, that's also a classifier. All right, so there are more categories that will help safeguard your system now. Okay, so spam classifier, very important. We use it every day. It's in the background. Word segmentation. So it seemed hard, it seemed difficult, but at the end of the day, word segmentation is a classifier. So we classify each character in the sentence, in the long string of text, whether it's a word boundary or not. So for example, บุญคุณต้องทดแทน, okay? So each character, we run a classifier on it, whether it's the beginning of the word or not. It's actually quite simple. We can train word segmentation today, but we won't. Okay? Yeah, so then we slide onto the next character, slide to the next character, and then run the classifier on each character. So that means you can run a classifier on a character as well, not just a sentence, not just one tweet, not just one article. And classifiers are, just same idea, it can be used at many different places. It can use it for automatic essay grading. So the input is an essay, very long, and give you the output A, B, C, D. People have been using this for a long time for, I think they're still doing it like for TOEFL, SAT, they do that actually. So with a human grader, you guys took SAT maybe? No? IELTS? How do you get in there? You took IELTS, right? Maybe?
But they use it.
IELTS, I believe they do. TOEFL definitely uses it, but not machine alone, okay? So they have a human grader and a machine grader and see if it matches. If it doesn't match, then they'll find another grader to grade it. So that's cool, okay? So that's awesome. So actually, one of the first systems are developed by ETS. They are like very dedicated to getting a very good essay grader. All right, good. Fake news detection. Oh yeah, fake news detection. That's a classifier as well. Input the news text, output the fake or not fake. Language identification. So you see on, what's that thing called, Google Translate? You can say detect language now, right? You can just type in anything and it will translate into Thai English for you. So because it runs a classifier on that text to see what language that is. That seems stupid. Why would you do that? If the input is in English text, it's English, right? If it's in Thai character, it must be in Thai. If it's in Chinese character, it must be Chinese, right? So why do we need a classifier? Anybody? Yes. Yes, that's right. So some languages use the same characters, which is a lot of the languages. Europe, think of Europe, all of those use Latin characters, more or less. Okay, so English, German, French, and there's those you can use a vocab even, but there are those that are very similar, but they're not so similar, and they insist that they are not the same. Like Scandinavian languages, Norwegian, Swedish, even native speaker look at them and still have to think a bit whether it's Swedish or Norwegian. So those can look very similar. So we actually need classifier for that. Japanese as well uses the kanji. Some of the kanjis are the same as Chinese characters. Thai, we have to be proud. It's used by one language. That script is only used by one language. Awesome, right? And our neighbors as well, Cambodian, also use their own writing script, Burmese as well, and many of the Indian languages also have their own written script, which is awesome. And so more NLP to do. And the last one, that's important now, intent classification. We use that for building a chatbot so that we know what to do if people want to put in an order for products, then it should be sent to different flow, right? If they want to talk, just to chat, then it should be sent to different flow. If they want to answer questions, it should be sent to different module for answering questions. So intent classifier, very important now too. All right. So far so good. Text classifiers. So you can use in many places. So a lot of problems can be solved just by phrase it into text classification problem. And once you know it's a text classification problem, you know what model you need to use. Okay, so that's the way of thinking that I would like you to have. Because again, code, you can always look it up. But to frame a problem, that's very important. Okay, we almost get to machine learning. Let's talk about types of classifiers. The first thing, there are 3 types now. Last year I taught there are only 2, now there are 3. The second one being LLM. Let's talk about rule-based. So rule-based actually works quite well. If you want to for example, distinguish between Thai text and English text. Only these two. You can write rule-based classifier very easy. Count number of English characters, count the number of Thai characters. Which one is more? It's that one. You know, that's a very good rule-based classifier. You don't need to train a model using machine learning, blah, blah, blah. So in some cases, it's actually okay, all right? So we see that in many things as well. When you use a form online, sometimes they check whether in phone number, you actually type in phone numbers. That's a rule-based classifier using regular expression. So those are classifiers as well, okay? So mostly we use regular expressions for those. Or, another thing is lexicon. You can use lexicon for that as well. So lexicon means a word list. Let me give you some examples why those can be useful. Oh yeah, spam classifier. We still do this as well, right? So for example, if you get a text on your phone and it's like some promotion from AIS, which you cannot unsubscribe, by the way. I tried unsubscribing that many times. They still send you the text. So in your brain, you already have like a rule-based classifier. If it's say AIS, if it's say Pro Max 15 gigabyte, you always just ignore that, right? So keyword-based classifier actually not bad. That's like one of the first classifiers we got. So if talk about if you see these word lottery, free money, it's definitely not free money, right? It's probably a spam or scam even. All right, so you could write a very easy classifier as this. Email classifier is some regular expression. We learned that already, and the code is something like this, right? It's not super hard. Oh, names. So you could recognize as well whether a string is a name or not. An easy way is to have a name list and look at the name list. If it's in the name list, it's most likely a name. Okay, so this would work for English because English names are boring because it sounds so un-PC when I say this, but English names are kind of boring because they're drawn from a very limited list. So, for Thai names, Thai people are quite creative with their names. Sometimes there are duplicates, but not very common because people keep coming up with new creative names, right? And those don't really repeat others. But English, I think the most common names like Sean for guys, like Sean, Mike, some Jacob, Edward, some James, same. So they're usually drawn from some like Bible or like saint something. So sometimes it's not very hard, okay? Where do we get the list of names from? Where do we get the list of names from? Say English name, where would we get those? National record. You can do that. Or you could scrape Facebook. All your friends' names. You get the name list and then get those. And you do some search and you get more names and you scrape those. So you get quite a few names from there. But from census, they keep the registry of names as well. Thai names is a bit harder or not. It's a bit harder now with PDPA because when government announces something, they have a long list of names, right? Say somebody who just passed their like GPA exam. That's a list of names. You get a free 500 names from there, and you can go back as long as you want. You could even study, how name changes over time based on these announcements, actually, because names do have trend and fashion as well. Anyway, so this is a very good name classifier for some languages anyway, where names are quite boring, right? And okay, I'll skip this one. Okay, rule-based classifiers, pros and cons. It's quite easy because you write 3-4 lines of code and you know exactly how it works. You know why it doesn't work because it's just 4 lines of code, and it scales really well because it's just if-else essentially. But again, not always good, right? So say a name of a person can be a name of a street as well, can be a name of the city as well. So it's quite sensitive to noise. So it's not that great. And then you have to tweak the function so that it works. Let me talk about LLM before we break, okay? Zero-shot LLM classifier is really good classifier. It's even easier than rule-based in some sense. What is zero-shot large language model classifier? That's really a long word. Let me break it down a bit. Large language models, that's the back end of ChatGPT, right? It takes advantage of transfer learning and some emergent properties. What does it all mean? So large language model is trained to do around 5,000 different tasks. Okay, so it should not surprise you that it can summarize text and translate text for you. It was trained for that, actually, specifically as well. But by training it on those like 5,000 tasks, it knows 10,000 more, which is awesome. So we call that emergent properties, good things that emerge. You know, emerge means just rise, come up unexpectedly. Okay, so we can take advantage of the emergent properties as well, which is a great invention for LLM. What does zero-shot mean? Zero-shot means the system performs the task without having seen it before. What do you mean models see something before? We don't code it up specifically for that, okay? We don't put in the if-else in LLM, right? But it just knows how to do these tasks somehow. And also, we don't give it label data, okay? So it's never trained on that, which is great, okay? So GPT-3 actually, the main invention when the paper came out is that it can do zero-shot task. So it can do many tasks. So from then we explore LLM and what it can do for us. But for now, even you don't know anything much about machine learning at all, you can write a very good classifier for NLP. Oh, question. Oh, all right. Why do people really want zero-shot classification now that you know what zero-shot means? Very little effort. Yes, it's easy. Yeah, very easy. Anybody can write a classifier. Okay? It's also free. You know, we don't have to make create a training sample for it. Train it. That's other things that we have to do to train a classifier, right? So zero-shot is awesome for that. And yeah, LLM can perform all sorts of tasks. Okay, and some of them are not classifier, but let's see how we can use it as a classifier. It's called prompting. Okay, so you write a prompt, and you leave the place for the input. We call that templatized prompt. So these are your prompt. This is your prompt. What is the sentiment of the following product review, which is delimited with triple backticks? This is really a big word. Delimited means to put it between something, okay? Why do I need to use this word? Because OpenAI told you that you should use this word. They told you specifically, use the word delimited with triple backticks, okay? It's in their manual. If you go look at their tutorial manual, they'll say, use triple backticks. So it's no magic. Because they train the model to recognize this, okay? All right? So, and this is important. So if you want it to become a classifier, tell it to give it the output as a single word, so that you don't have to parse it, because LLM would just go, right? And that wastes your tokens because you pay per tokens. And it's also faster. Just like give me the answer, please, and it'll give you the answer, just one word, and then you know that it's a label, and that's convenient and cost-effective as well. And this is the templatized part. So you put in the text that you want to classify here. It can be very long because LLM has this awesome property of reading a very long text, right? 10 pages, 100 pages of something, it can read that. Well or not, that's different answer, but different story. But yeah, you could do something like this. Put the string in here. Okay. Oh, what do we do here? Oh, sentiment. Okay, and LLM classifier is important to talk about this now as well, because sometimes you can't get really specific training data. Say, for example, you want to know how many reviewers, how many of your customers are angry. Angry is not a sentiment. Angry is an emotion. Do people make a data set for emotion yet? Maybe, but you can imagine tasks that are so new and so specific that you can't train the model for. So LLM is great for that. It should know what anger means. I think it does. Okay? Same trick, delimit it with triple backticks. Okay? And then you put the text in the between triple backticks. Triple backticks is good because it won't collide with the text in there. If you use quote, it might confuse it, right? If you whether it's an opening quote and the closing quote for here, or the quote that is in the text itself. That's why they encourage triple backticks. Same trick, give your answer as either yes or no, and you can write but nothing else to be sure, so that you can just grab the first string and you know it's a label. Example 3, something even more specific, okay? So this is intent classification that I talked about. So given a message, you want to classify into, what is it? Greeting, goodbye, FAQ, order placement, booking, information request, feedback, small talk, complaints, user assistance, any labels that you want. And if one day you want to expand your classifiers to cover more labels, what do? You change the prompt and you're set. Amazing invention. And again, you could put it around triple backticks, which is encouraged. For this one though, I make it a little bit special because I want JSON format. And the key is label, the other one is reason, if you want to know the reason as well. JSON format is great because then you can turn it into a dictionary. Once you turn it into the dictionary, you can do whatever you want, right? You can put it into the table, you can put it into Pandas data frame, CSV, Excel, whatever you want. So this is another trick that you want to use the LLM for. Once you have the right prompt for it, you could use the OpenAI, not the OpenAI client, but you could use any model that you like. Now it's old. GPT-4o mini, rest in peace. Now it's GPT-5. My slide get outdated so quickly. This is from last semester. So I think 4o mini should still be around, I think, for API call. So yeah, so you write a prompt, right? This is templatized, right? See, I leave the space for the text to be classified right here, right? And then when you want to use it, then you replace the where did I replace the text? I never replaced the text with that. Oh yeah, no. This is an F string. Okay, so the curly bracelet here will grab the parameter from the function and replace it here. So this is the kind of code you would use to use LLM as a classifier, and all you have to change is the prompt. Okay? Good? Yeah, that's it. This is a classifier. So you learned about 2 types of classifier already. All right? So, and that's zero-shot classifier. They're awesome, but soon enough you see that they're good at many things, but they're not the best at anything. They're really not. We want it to be the best at everything, because then you don't have to take this class anymore, because then you can just prompt an LLM, right? And then you're good. But no, you have to learn how to train models, because you can make a better system than LLM classifier. Okay? Okay. LLM is very useful still, because some tasks you can never train the models for. If you want to classify whether a letter, say you have a letter, whether it's suicidal or not. It's so rare that you're gonna get letters written by people who going to, do bad things to themselves, right? So those are rare data that you never get to collect, right? And they're protected. It's hard to get your hands on. So these are very useful for tasks that you can never get the data for, which are many actually. But the thing is, LLMs are expensive. Do you know why it's expensive? You have to, yeah. Yes, because the models are so large, so you need, so OpenAI, Google, what's the other guy? Anthropic would have to rent or buy really good computers to host it. So that costs money, as in the machines themselves, and the electricity to run it. And it correlates exactly with the number of tokens. So the more you use, the more expensive it is. Unlike many things, right? Unlike app that most apps that are on your phone, it costs the host machine almost nothing. But this will cost per token that you use. Okay, so it can be expensive if you want to process a large amount of text. For example, this Thai LLM called Typhoon, right? They claim to be like really good Thai LLM, which it is, right? And I heard from Typhoon team that one of the top uses of Typhoon LLM is Thai word segmentation. So Thai word segmentation would need to use GPU, host it on like 4 machines to run word segmentation. But we just did word segmentation on free tier Colab, right? So that's always a thought as well. If you have like a cheaper option to do the same thing. So don't use Typhoon LLM to do word segmentation, because you're gonna have to run 10 million tokens at a time, right? And that would get expensive very fast. Okay, now it's 2:40. We'll come back around 2:55, and we will talk about machine learning based classifier, and we'll talk about naive based classifier.